Good evening, good afternoon, good morning from wherever you are joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor livestream event. Today I would like to welcome Stefano Tempesta. Hi Stefano.
Hi there, hi Sarah, hi everybody.
Stefano, he works at Microsoft in the Azure Confidential Computing product group to make the cloud a more secure place for your data and apps. Today we will learn how to protect your data in the cloud with Azure Confidential Computing. This session will be approximately 60 minutes with about 10 to 15 minutes for questions at the end. However, do send us your questions throughout in the Q&A section and we will try and answer as many as we can towards the end. At the conclusion of this session also, we'll share a link to our feedback survey in that Q&A section. And we'll also, for your reference, if you've missed anything from today's session, we'll be uploading it to YouTube in the next 24 to 48 hours. We'll also share the link to our YouTube channel there. But for now, without further ado, I'd like to hand the floor over to Stefano to begin. Stefano, over to you.
Excellent, all right, so welcome everybody. Confidential computing is a quite important topic that I would like to share with this community, and it is because it addresses some very specific concerns of security and trust in the cloud. Why confidential computing and what is special about doing computing in a confidential way and in the cloud? We are looking into addressing areas of untrusted access to data and application. Is about preventing unauthorized access, as simple as that. So obviously we don't want anybody to access our data that is stored in the cloud if they don't have an authorization to access it. But it's also for regulation and compliance. So to protect data that is in use among different applications and among different parties. It's also protecting from sort of government access or from the cloud provider itself, or in general to facilitate a trusted collaboration. So protection from collaboration where different parties have conflicting interests into the data itself. So the motivation is to protect additionally your data more than what already happens in the Azure cloud, where you have already different mechanisms for protecting your data at rest and in transit. This is an additional level of protection, a protection from here we go, the animation fills in, protection at hardware level, protection at hypervisor level, protection at virtual machine level, all elements that are typically in the responsibility of the cloud provider. With confidential computing, we are introducing a protection with hardware-based encryption of a memory space that runs inside a virtual machine that is based on an hypervisor, that is based on a physical server, and all these levels are protected. So not even the administrator of the virtual machine, not even the host admin of the hypervisor or the technician with access to the server can access your data in the cloud. This is a level of protection that you don't normally have with data that is protected at rest or in transit, because as I'm sure you know, protection of data at rest is when it's stored in some storage, database, file system, but then you take the data and you move it in memory. So the transit is also protected, HTTPS, SFTP, whatever protocol you will use for encrypting data in movement. That's okay, but as soon as your data is in memory, so it is in use by the application that is consuming it, someone with access to that server, to that virtual machine, can take a memory dump and see everything that is running inside that process, inside that memory. And here is where confidential computing can add that extra level of protection. blocking the access to the memory space completely. And this is done at CPU level. Now, if you are familiar with the concept of addressing memory in use, no? in a virtual machine, in a server in general, a CPU will resolve an address to access that specific memory and return the value that is in that memory. With this level of encryption that is done at hardware level, so at the CPU level, that address is like it doesn't exist. It's a black box. It's completely invisible to any application, any request that is outside of this enclave. And the word enclave is not coincidental. There are different applications that are built inside this enclave, and there are different use cases that benefit of this extra level of protection in different industries. Typically, they all go in a few use cases. Now, irrespective of the industry, but we are looking into creating trust among multiple parties that need access to data that otherwise they wouldn't typically share because it contains sensitive data or PII, personal identifiable information. Data that is patent, for example, or data that is used for identifying medical records or credit records or anything that is particularly sensitive and different organizations obviously don't want to share. Now, a few use cases in general. I'm gonna go through a couple of them today. I'll touch on a few areas of these use cases and show also a quick demo and a reference architecture in the time that we have. Please post any question in the Q&A session. Happy to take it as we go. I'll pause for a moment before jumping into the demo, and then obviously a bit of Q&A at the end, and then feel free to reach out directly for any follow-up questions you may have. All right, so this is the context, okay? So we said that confidential computing is all about protecting data in memory, so to prevent access using hardware encryption when data is in use. And it is extremely sensitive, highly confidential data that we don't want anybody to access, including the cloud provider. So that's the context. Now, how do we do it? How do we build this extra level of protection? We do it with, I was expecting another slide, but I'll jump into this. We do it with something called Enclave or Trusted Execution Environment. But before we go into that, let me add another word about this slide, which is one of the champions of confidential computing at the moment. I'm sure that you have heard a lot about Signal, the app that has end-to-end encryption, including the social graph, including the contact list. So these contact lists are not even persisted on any storage. They are kept in this confidential enclave, and from there, obviously, only the app can access and resolve the contact phone number and associate with a specific device, and no one else. So in this way, obviously, you understand that by protecting the access to this contact list, data cannot be used for targeting specific ads, cannot be shared, cannot be sold. And this is one typical use case where we see a lot of benefit of this trusted sharing of data. Think for a moment, this is fraud detection, but it can be any machine learning service where we want to make a prediction of some outcome based on a historical pattern. So the larger the source data set, the more appropriate and more accurate is the prediction. So in this case, the outcome can be an increased detection rate, a reduced number of false positive in the fraud detection. Banks have their own historical data set, and they typically run some machine learning on their own data source, which is obviously extremely confidential, and very likely they don't want to share their own data with anybody else. Now, think for a moment, what if all these banks, which you appreciate they may even be in competition among each other, actually could share their data set in absolute confidentiality, make it as an aggregate of all the customers' data over years and years of historical data historically collected from all their customers, and then run a machine learning that instead of running on, say, 100,000 records, it runs on 500,000 records, 5 million records, or even more, right? So this will generate an incredible improvement in the accuracy of the algorithm itself. Now, the challenge obviously is banks will never share this data, even if you say, oh, no worry, I'm going to encrypt it in the cloud, in some storage that is super protected with some very sophisticated key. The problem is still there. It's still the encryption is a software encryption, is a weak point that can be compromised if the key is compromised, if the key is lost, is hijacked. Now, in this context, a centralized machine learning service running in an enclave, which is a black box, is a trusted execution environment where only the authorized banks can send their data with an attestation that authorize submitting this data. This machine learning service can actually read this data set, and no one else. So if bank one obtains the key from the attestation service, and I will speak about this in a moment, and then upload the data in this enclave, no one else can get the data out of it, because this data resides inside this memory space, which is accessible only by the machine learning service. Not only data can be protected, but also the code, the source code of the machine learning service can be protected, because it's a memory space. So you're running not only data, you're also running process, you're also running an application. So in this case, a machine learning service. It's also, the benefit is also a protection of your IP, your intellectual property, when running this sort of application. All right, so before we go into a little bit more technical details, just a quick word to say that all this initiative at Microsoft is part of a larger consortium, the C3 or CCC, the Confidential Computing Consortium, which has different players from the industry that are all contributing to creating a standard definition of confidential cloud. It's important I mention this because you want to stay away from proprietary implementation of hardware encryption, which will lock you into that technology, and instead try to adopt a mentality that is more oriented into collaboration. And also, as I will mention in a moment, will benefit of plenty of open source frameworks that are available there in the market for building applications that can communicate with this black box, with these enclaves. Okay, so think when you're considering adopting a technology for confidential cloud, for confidential computing, look if this is part of the Confidential Computing Consortium first. And my recommendation, try to stay away from something that doesn't fit into the open source market, or even if it's not open source, if it's commercial, that's okay, but as long as you have the CCC to back you up on that. All right then. Specifically speaking of Microsoft, our website is on screen, azure.microsoft.com, but you can just search for Azure Confidential Computing and you will find it at top of your search result. There is one key capability that I want to draw your attention on, which is the data and code that run inside a confidential computing environment is opaque to the cloud provider. So it means that not even Microsoft, no one ever can have access to data that you run in the cloud, simply because we don't have the key to decrypt the access to this memory enclave. Only you generate your own key. The attestation, so you own it, you store it, you save it somewhere. The attestation service will use that key to authorize you access to the enclave, and the enclave knows that only that request with that key is authorized to open the data and open that memory space, open the enclave and access it. All right, so a little bit of additional details on technology. This is done at hardware level, I mentioned, and specifically, this is Intel SGX hardware extensions, software guard extensions, literally. These are extensions to the CPU. There are special CPUs, typically from the Xeon family, that have these memory encryption at CPU level with a key that is wired inside the CPU itself. So each CPU is different, is special, is meant to have the encryption key. And the CPU will protect all the way up at hypervisor, operating system, until your virtual machine or containers have the application and so code and data running completely encrypted. It is called protected enclave. It is a memory space allocated, reserved exclusively for these for the use, for the protection of your code and data. In Azure, you can obtain this with a special family of virtual machines called DC-V2. These are confidential machines, virtual machines that run on Intel SGX CPUs. And obviously, you appreciate that from a geographic perspective, there is a dependency on having these SGX extensions available in different regions. At the moment, we are covering some regions, with Australia coming soon in the next few months, and obviously broader presence in the US and Canada and Europe, where there are some requirements from compliance perspective, data residency, you may be aware of GDPR and the like. So this is just to mention again that the strength of this technology is based on hardware. Therefore, there is a dependency on having hardware available in different regions. All right, so before we proceed, Sarah, can you notice any question in the chat before I jump into the demo, or are you good to go?
Yes, we do have two questions, thanks, Stefano. Right. So first question is, technically, what is the difference between trusted execution environment and enclave? Sorry, I don't know if I said that correctly.
Yeah. But look, these are often used as synonyms. Enclave is specifically associated to the Intel SGX technology because it's an implementation of a trusted execution environment. There may be different ways that you can implement a TEE. Enclave is the sort of the Intel SGX implementation. But the market is not broad enough to have different flavors just yet. It may come later on. So for now, these two terminologies are very often used as synonyms of each other. Although technically, a trusted execution environment is any kind of environment where code and data is trusted and protected from external access, and an enclave is the specific implementation made with Intel SGX. Good question.
Great. Well, we have 2 more questions. So how is confidential computing better than fully homomorphic encryption?
Yes, for some reason I was expecting this question. FHE, full homomorphic encryption, is a fantastic technology that encrypt data in memory, and it is different approach though. Confidential computing is not encrypting your data in use, it's encrypting the access to the perimeter to the data. But when data is running inside the enclave, is in clear text to the application inside the enclave. So the enclave is a black box from an external access, so no one can access the enclave. But once you are inside the enclave, because you have the key, you have the attestation, then everything inside the enclave is clear text, and the encryption is done on the perimeter, hardware encryption. The fully homomorphic encryption instead protect data all the way. There are pros and cons on both approaches, right? The benefit of the enclave, so of the SGX approach, is that encryption is a hardware level, so it's extremely optimized, high performance. And the benefit, and the sort of, I would say, I don't like to call it disadvantage because it's not really a disadvantage, but the position of homomorphic encryption at the moment is that by being a software encryption, without the proper highly performant hardware, it will struggle to meet the same level of performance of a hardware-based encryption. So don't quote me on this, but homomorphic encryption tends to be a bit slower than hardware encryption, simply because you're doing a software encryption. When we'll have homomorphic encryption done at hardware level, we probably have some level of comparable level of performance. But the two technologies don't exclude each other. It's just a different approach to protect data in memory.
Okay, great. So one more question. There have been a number of side channel attacks diagnosed in Intel SGX. Is there a plan to move to another vendor?
Excellent question as well. Okay, so let me clarify, because obviously the media, the press tends to exaggerate a bit, let's put that way. Now, it is true, Intel SGX has been subject to different attacks, but these attacks require physical access to the CPU to tamper with it and compromise it. So this means, think for a moment, Azure data center with thousands of racks, each rack's hundreds of servers, each server's running dozens of virtual machines. Before you can actually find and access the enclave that you want to steal data from, you need to, find the Azure data center, and very few people know where actually it is. We know that it's in Australia East, Australia Southeast, so say Sydney and Melbourne, but there is no address that you can easily locate. Then you need to get access to the data center. Then you have to find the actual server, the physical server. Then inside the physical server, you have to open it and compromise it. Well, if you do it, congratulations. It's a Mission Impossible movie to do after that. So it's very, very hard to compromise a CPU. There has been some some precautions made by Microsoft. For example, disabling hyper-threading, because hyper-threading could hijack a thread running in the CPU to access the thread within the same CPU that is protecting the enclave. So that is disabled in Azure. And there has been some other precautions like a dedicated host, so that you can have your dedicated host, so your dedicated virtual machines without sharing with anybody else. And so that will prevent also sort of a side attack. Your question though asks also if we are considering other vendors. Microsoft is considering other vendors. Stay tuned, because next week we are making a big announcement with other vendors, not as an alternative, but as an addition. Intel SGX is super strong. It will stay in the market for longer, and we are fully committed to Intel as a partnership. So Intel SGX will keep on going for sure. And actually there are new announcement also in Intel SGX that are under NDA at the moment, but I can tell you, stay tuned. But as well, Microsoft is running also partnership with other hardware vendors and propose additional trusted execution environment technologies in the market as of next week. All right. Let's jump into the demo now, and then we take a few more questions later. The first one is purely a screenshot. I install WinDebug, which is an application that takes memory dumps from servers. I install it into a virtual machine, into one of those DC V2 series virtual machines. And inside the virtual machines, I configure an enclave. Then I try to take a memory dump of that enclave. If you were running some other form of encryption, including the homomorphic encryption that was mentioned before, you will probably see some scrambled data, which is encrypted. And obviously you can't do anything about it because it is encrypted, right? You will need the key to obtain access to that data. Fair enough. But in this case, you don't even see the memory address. So WinDebug is telling me, hey, I don't know what you're asking. That memory address it doesn't exist. It does exist, but it just is the CPU that is not releasing the address. It's not telling you, hey, you can actually take a dump of it. It's like it doesn't exist from any application running outside of the enclave. So this is the difference with homomorphic encryption. We don't see encrypted data. We don't see full stop. The difference, it just it blocks the access to that data from the outside completely. All right, now inside SQL Server here, hopefully you can see it's a little bit small. And SQL Server has been running encryption and REST for years and years now. So I have two columns that are encrypted: social security number, SSN, and salary. Nothing new, nothing confidential here. In terms of confidential computing, this is a standard capability of SQL Server. I'm encrypting two columns inside a table, just two columns. And then I have a .NET application that is running in a web browser and is displaying this social security number and salary on screen. Data is encrypted inside the database, and then I can show you here on screen. But the challenge here is that I have some filters. Filters as a slider for the salary or as a text field for social security number. So if I run a SQL profiler, I could intercept, I couldn't actually see the query itself. So the SQL profiler could reveal sensitive data that is encrypted in database, because it would be a parameter in the where condition, like this SSN or salary. And then it will obviously reveal data that I don't want to make available. But because this is running in an enclave, it is fully protected, fully encrypted. So a SQL profiler will not be able to see anything in clear text. These even the parameters running in memory, so this is purely in memory, no? The profiler is intercepting the SQL statement in memory, is completely unreadable from our external eyes. And then obviously when this goes inside SQL Server is running inside the enclave and is able to understand what all these numbers means, all this encrypted number means. So and this is done with a special version of a client, a driver that connects to SQL Server, that has been enhanced to be able to communicate to SQL Server. It supports different capabilities to communicate with the enclave. So remember, data inside the enclave is in plain text. So SQL Server inside the enclave runs with data that is never software encrypted. And this is a good thing. Data never leaves the enclave for encryption and decryption, as it would happen if you were encrypting and decrypting data with a software library. A software library, you would run some asymmetric key-based algorithm like AES or triple DES and encrypt data in transit or in use. Whatever you do, it will be a software encryption, which is a weak point, a weakness if the key is compromised. In this case, data is never leaves the enclave. It just runs inside the enclave, and then this driver, by obtaining an attestation, so by obtaining a secure communication with the SQL engine and with the enclave, is able to communicate then with the SQL engine. Okay, and this is the case of the attestation. So you start with a DC VM, which is the special virtual machines that run on Intel SGX. Then you create a communication with Enclave. When you see OE SDK, that is the Open Enclave SDK, which I may be able to quickly show you. You go into openenclave.io, okay? So openenclave.io, or just search for Open Enclave SDK. This is your software development kit for building applications that are able to communicate with the enclave. You may see here, okay, your application is doing a communication with the enclave using obtaining the necessary attestation for communication. This is completely open source, is on GitHub, so you can take it and start building your applications directly with this SDK. Now, in the case of SQL Server, we have done this for you. So we have enhanced the client driver, so you don't have to bother about using this OE SDK. The enhanced driver is already taking care of the communication, getting the attestation, and establishing the communication with the enclave. There is another quick demo I want to show you. This is another multi-party computation using machine learning. Different health institutes, let's say Hospital 1 and Hospital B, or Hospital 1 and 2, or 3, they are sharing some data set, and they all go into a machine learning service. With this machine learning service, will improve the accuracy of prediction. So I have recorded very briefly this demo. So I have a data set here that contains some data for training of a machine learning model, and I'm going to do two things here. One is connect as a user A. So say I'm part of the hospital A into a UI fictional UI at this stage for uploading this data set into a machine learning that is running in the Enclave. So you see the user B hasn't posted anything yet. So I'm just as user A. User B has not uploaded any file. And what I'm gonna do is now upload my my data set that I have also additionally protected before. Now switch to another virtual desktop just to simulate the user B, so the hospital B. So pretend this is another hospital somewhere else. They are running their own data set. So they're going to do exactly the same operation. They're signing in into the same application as user B, obviously. Now user A has uploaded one file before, and now user B, hospital B, is going to upload their own data set. Once this is done, a training of this data set starts automatically. And now I want to evaluate the performance of this train model. So in this little application here, I switch to the evaluation. Obviously, I need to download my train model first. So I save my model that I have obtained from that I trained before for user A and user B. When I do the evaluation, the local model is the performance of the local model, so user A only, and it comes out as 84%, which in medical industry is medical space is not that great, to be honest. You know? 84%, we can do better. Just by combining the two data sets, and these are just two of them, the accuracy increases massively. All of this is on GitHub, open source. So feel free to start these samples and see.
Okay, you should be good to go now. Thanks, Stefano.
Okay, yes, welcome back. Or I should say to myself that welcome back. I don't know, I got disconnected for a moment. Anyway, we're nearly at the end. I want to share a little bit more of the services that we have in Azure, because I talk a lot around the virtual machines here and there, DCV2 and SGX, but actually Azure is it's the cloud with the confidential computing offering that I believe is the richest in the market, simply because we are targeting confidential computing not only as infrastructure as a service, so virtual machines, but also with PaaS, with platform as a service, with a variety of offerings for enabling you as an organization, as a developer, to build your application with the best tools that you normally use. For example, containers, very popular nowadays to build your application on containers. You have the possibility to deploy your confidential containers in Azure. It went GA, so general availability, just a couple of weeks ago. And there are different partners that you can see on screen that have implemented some specialized version of these containers. So Azure runs the infrastructure to run your AKS, your Azure Kubernetes services on confidential hardware. And then partners have enabled this infrastructure with frameworks that allow to package your application without going into the low-level coding or communication with Enclave. So you can use partner solutions for excuse me, for bundling your containers in Azure, your confidential containers in Azure, or you can do it yourself. So you can use a number of frameworks that exist in the open source space, like Graphene, Oclum, and there is a third one called Mysticos that has been published recently. So get in touch if you want to know a little bit more how to do it. The idea basically is that you bundle your application with either a partner solution or with an open source framework, and then you publish in Azure as a confidential container. SQL already mentioned, so the possibility to store your data inside a SQL engine inside the Enclave, and there is nothing else for you to do except writing your query, because we are taking care of the secure communication to the Enclave. The enhanced driver is doing all the nitty-gritty configuration at SGX level. If you are into the IoT space and you are particularly sensitive to collecting data at the edge, confidential data at the edge, then your IoT edge secure enclaves will collect confidential data and stream to the cloud without inside the enclave itself. And a new service which we are about to announce soon is a confidential ledger based on the confidential consortium framework, which is baked up by blockchain technology. You have the possibility to generate a tamper-proof digital ledger that you can use as an immutable transaction log that is available as a service with an API ready for storing all your transaction in an immutable append only, a little bit like a blockchain, but without the decentralization and without the proof of stake, proof of work that you don't need, because there is no cryptocurrency involved in here. You're getting the benefit of the DLT, the digital ledger technology, without the complexity of a decentralized network. And that's it. So additional resources, I already mentioned the Open Enclave SDK. Start to learn more about confidential computing. Just search for it, Azure Confidential Compute, or the URL that you see on screen, and Sarah will post in the Q&A, so you can access from there. Get in touch, my email address is on screen, or you can just fill in a customer request, and that goes directly to me, and I can follow up with additional information. Thank you very much for your attention. Let's take a few questions before we end for today.
Great, thanks, Stefano. So it does appear that we have a couple of questions coming through. So first one is, SGX remote attestation has also some known vulnerabilities, e.g. reuse attacks. Do you add something on top of SGX remote attestation?
Yes, thank you for the question. I probably forgot to add a slide for that, because as of last week, we have a Microsoft Azure attestation service. So let me see if I can find it easily, otherwise we'll do it another time. But Microsoft Azure attestation, let me see if I comes out on top of the search result, is our managed attestation service. So if you use the MAA, the Microsoft Azure attestation, you will not need to get attestation from Intel SGX attestation service any longer. The idea is to have a managed attestation service, and also to make it future-proof. So then once we introduce a new technology, oopsie, it's not opening. Okay, once we introduce a new confidential compute technologies that are not necessarily SGX, then you don't have to change your attestation service. You can leverage MAA for all your attestation needs. But okay, I don't know why it's not coming up, but it's just search for Microsoft Azure attestation and it should come out. Great.
So there is one more question here, and someone has provided a link. They say AFAIK, at least some of the Intel SGX exploits need no physical access to hardware, such as this one, and they've provided a link. Is there any plan to address this issue down the road, perhaps in the Azure SGX offering?
All right, let me see if I'm familiar with that. But
so if you just go to the publish section and down the bottom there.
Yeah, here we go. All right. So the question is, this vulnerability doesn't require physical access. Okay, look, to be honest, my focus is more on the software side rather than the hardware side, so I may not be aware of this, and it's not opening, so I don't know what's going on. But how about we do this? I'll take it back. Yeah, it's not open, strange. I'll take it back. I'll do a little bit of due diligence and research into this, and get back with a post on some social networks. So follow me on Twitter or LinkedIn, or just reach out directly to me. Let me post my email address, and I'll be happy to follow up. Short answer: if you don't need physical access, then it may be a problem. And what Azure is doing, what Microsoft is doing in the Azure Confidential Computing is the two things that I mentioned before. One is a dedicated host, the other one is disabling hyper-threading. And third, maybe I shouldn't say this, but the third is that we are working very closely with Intel to apply a number of patches and also a second generation of Intel SGX CPUs that are coming soon, which is expected they are addressing all these vulnerabilities. There is no ETA for that, work in progress. I said, stay tuned. This is a new market, a new scenario, a new industry, this confidential computing. And so it's evolving. And as you can expect, initially there may be some challenges of adoption and delivery, but over time, I'm sure it will get better and better. But thanks for this. Is yeah, for some reason it's not opening, but it's great. It's great to see that there is a strong interest, and I see the audience is pretty knowledgeable already with vulnerabilities and alternative technologies. So stay tuned, because Microsoft is definitely investing a lot into this space. Anything else, Sarah? Oh, we're good.
Yeah, so one last thing. Someone just says, thank you for this question. They say, very interesting. Can you please do a session on Microsoft Azure attestation, please?
Okay. Point taken. We'll follow up. If Sarah allows me to do it, I'm happy to do it.
Of course. We're happy to have you back again to the reactor. Well, I think that was the last from the questions. So what I'm going to do is we'll wait one more minute to see if anything else comes through. But in the meantime, I'm just going to put a link to our survey in the Q&A section, and also just a link to our website for any upcoming events. Hopefully we'll have Stefano on for another event in the coming months. Just going to pop that all there. If not, thank you, Stefano, for joining us today, and thank you everyone for tuning in wherever you're joining us from today. It was a pleasure to have you here, and just a reminder again that we will be uploading this to YouTube within the coming days. So just make sure you check out our YouTube channel, which I'll also share our link to in the Q&A box right now. So keep an eye on that, and it should be up hopefully within the next 24 to 48 hours. No questions, Stefano, so thank you very much again for your time today, and thank you to everyone for tuning in. We'll see you again for another live stream Reactor Sydney Microsoft event.
Bye, everybody.